it will become 1. That is why if you summation them 1 plus 1, which will become the 1, and the carry will be also 1 because x and y, because here the x value is 1 and the value of y is also 1, so 1 into 1 will become 1. That is how the formula works for this table. This is the circuit of half adder and full adder. In this section you can generate the summation by x and y, then we are having the XOR value by this one, and carry is the simple addition AND function, which is the multiplication function, which will works like this one. You can also draw it like this circuit. If you want to do the binary additions, you can go through by this one. This is nothing but the two half adders. In this half adder section, the half adder will look like this. In this section we have two half adder. One is this one and another is this one. So after two half adder, conclusion makes one full adder section. This works as the full adder section. Just follow the value of sum and value of carry. If we go to the full adder section, then we can see this. The value of carry and sum are similar to this diagram. So in this diagram a full adder is working. In this section we have 4-bit adder. Here we have consecutive adders, and here A and B are giving their values, and here is C for the carry. In this section we are getting 3 inputs, and for that we are giving an sum output, and the carry section is moving on to the next. First we have the carry, which is 0, and then we have passed the carry C1 to the next one. That is how the 4-bit adder works. The propagation delay is the processing delay of this, because here the second FA is waiting for the input of C1, and FA is this FA is waiting for C2, and this FA is waiting for C3. So that's why if the C0 is not come and doesn't get the result, there another FA are waiting position. So that's why this is known as a propagation delay. Half subtraction is not very much important, but you can have a snap of this one for your future study. Here is a borrow section, and this is the differential output. Here is a diagram of full subtraction. Half subtraction and half subtraction make it the full subtraction. Now the important section in this is the encoder. An encoder transforms the data into an encoded system. That is why anyone cannot easily understand that. In this section we have 4 inputs, which are from I0 to I3, and outputs are from O0 to O1. So in this section we are transforming 4 into 2 encryption. Here we have 2 to the power n input and n output. That is why here we have 2 to the power 2, that means 4 input, and in output section we have only n output, that means only 2 output. That is how the encoder works, and this is the basic diagram of encoder. In the session we have 1, so 1 on I0, which will denote as 0. Then this will on the 1 section. In this binary we have 1 here, which is 0 1. This is on section 2, which is in binary, which is 2 and 1 0. This is in the 3 position. In binary, we denotes 3 by 1 1. That is how the encoder works. This is also the parity encoding for input and output of encoder. Here we have X, and those X are denoted as parity. Now we are in the decoder section. In decoder section, decoding is just opposite of encoding. A decoder is a circuit that has changed a code into a set of signals. In this decoder section, we have input A1 and A0, and we have decoded data as from D3 to D0. That is the opposite diagram of encoding section. Here we have 0, 0, 1, 2, and 3. And in the section we started from D0, which is the 0, 1, then 1 and 2, and last one is a 3. In the section, input will be n and output will be 2 to the power n. That's why we have input 2 and output is 2 to the power n, which is 4. This one is the diagram of this decoding section. Here we have input A0 and A1. In the section, first of all, we have 0, 0. That means the value of A0 and A1 are connected directly to D0 section. Then 0 and 1. Then in the section we can say that 0 is created by when the value of A1 is not section. In the section of D1 is connected with the value of A1, which is created not, and the value of A0, which is connected directly. That means the value of A0 is 1, and for not, the A1 value is getting 0. In this last section, which is D3, we are getting directly the value of A0 and A1. That is the reason we have this connection like this, which is getting the value of A1 directly, which is 1, and A0, which is directly 1. That's how the 2 to the power 2 to 4 line decoder works. Here are some description about inputs and outputs. 3 to 8 decoders are working as same. In this session, you can see that in the first D0 session, we have the value as A1 is 0, A0 is 0, A1 0, and A2 is also 0. So here the input is 0, 0, and 0. Then another one is A0 is connected with the NOT section. That means A0 is 0. Then the A1 is connected with the NOT section. That means A1 is also 0. But A2 is connected with the direct line, which is 1. That means the outputs of these inputs will like 0, 0, 0. Then again 0, 0, 1, which is the 1. Then 2. Then 3. Then 4. Then 5. Then 6. And lastly the 7. Those are the 8 to 3 decoders. In this section, we have the input value is 3, which is n, and output value is 8, which is generated by 2 to the power 3, which is 8. Now we are in the multiplexing section. In this multiplexing section, we have n input signal and m control lines to have the output signal. Here we have 4 to 1 multiplexer. We have 4 inputs here to generate one line, and here are 2 selection bits, which are S0 and S1. The selection bits selects the output. In 2 to 1 line of multiplexing, in this section we have 2 inputs in one line. Here we have the enable section. When the enable is 1, the S is the selection input is 0. And when the value of E and S is 0, 0, it will select the value A. and when it is 0 1 it will select the value B. E is for enable and S is for selection. This diagram is not so important, but this 4 to 1 multiplexing diagram is very important. Here S1 and S2 are selection inputs and I1 to I3 is for the normal input for getting one output, which is Y. Demultiplexing is the opposite of multiplexing. Here we are having 1 to 4 demultiplexing. Here we are having the input as 2, which are A and B. We are having 4 outputs, like as Y0 to Y3. Here we have a data line, which is common in everyone. This one is data line. This one is also data line. This one is another data line, and this one is also another data line. And A or B are our inputs for them. That's for today. Thank you.